You were taught that plants make the oxygen you breathe. That's not the whole story. Because 2.5 miles down, in total darkness, something with no leaves and no life appears to be making it too. Deep beneath the Pacific sits a vast, crushing, lightless wasteland. Nothing down here should be able to breathe. And yet, sensors on the sea floor caught something that shouldn't exist. A phantom breath stirring in the deep. Scientists call it dark oxygen. And if it's real, it doesn't just rewrite where oxygen comes from. It could rewrite how life on Earth began. Before we go down there, hit subscribe and ring the bell so you never miss what's hiding under the surface. Our story starts in 2013. A marine ecologist named Andrew Sweetman lowered sensors into the abyss. He was studying the clarion-clipperton zone, an underwater desert stretching across the Pacific. This place is bigger than the country of India. Sweetman expected to watch the oxygen slowly fall. That's what should happen. Deep sea life eats whatever sinks from the surface. But the data did the opposite. Inside his sealed chambers on the sea floor, oxygen was rising. He assumed his expensive gear was breaking under the pressure. He wrote it off as bad data and moved on. 8 years later, he went back. New site trip, a completely different way of measuring. And the impossible readings came back exactly the same. Oxygen was being generated at the bottom of the sea. No sun, no plants. So Sweetman's team went hunting for the source. First suspect, some unknown microbe, quietly breathing out oxygen. So they sterilized the samples. They sealed the seawater and mud in airtight containers, cut off from everything. And the oxygen still spiked, to 3 times the background level. Whatever was doing this wasn't alive. It was chemistry. The team traced it to the strangest objects on the sea floor. Lumpy black rocks called polymetallic nodules. These things look like burnt potatoes, and they litter the deep Pacific in fields that go on forever. Each one takes millions of years to grow a few centimeters. Metals drift out of the seawater and slowly crust onto a tiny seed, often a shark tooth or a fragment of bone. The result is a rock packed with valuable metal: manganese, nickel, cobalt, copper. Back on shore, chemists tested what these lumps could do electrically, and a single nodule measured almost 1 volt, 0.95 volts. That's a lot of natural voltage for a rock. Splitting seawater into hydrogen and oxygen takes about 1.5 volts, roughly the punch of a household AA battery. One nodule falls short, but they don't sit alone. They form vast fields wired together through conductive saltwater, like millions of tiny batteries linked in series. Stack those voltages and you cross the line. The current tears water molecules apart, and out comes oxygen. The team called it the geo-battery hypothesis. Bigger nodules seem to make more oxygen. Some researchers even wonder if these fields behave like a faint electrical network humming across the sea floor. But here's the twist. This shocking new discovery may have been stumbled onto half a century ago by the CIA. In 1968, a Soviet nuclear submarine, the K-129, sank in the Pacific. The United States desperately wanted the technology on board, so the CIA launched a top-secret recovery mission, Project Azorian. They needed a cover story, and they picked a perfect one: deep-sea mining. Billionaire Howard Hughes built a giant ship, the Glomar Explorer, and told the world it was there to harvest metal nodules off the ocean floor. In 1974, they dragged their claw across the abyss to reach the sub. And on the way, they really did haul up thousands of these polymetallic nodules. The cover story was fake. The rocks were real, and the government quietly mapped the fields covering the Pacific floor. And those fields are far from dead. Scientists have since catalogued more than 5,000 species living down there, and roughly 90% were brand new to science. Some creatures live directly on the nodules. Certain microbes don't even eat food. They're thought to pull electrons straight from the rocks. An alien-looking ecosystem thriving in the dark. Now, here's where it gets messy. When the study came out in the journal Nature Geoscience, it set off a scientific brawl. And a lot of the pushback comes from the people who want to mine these nodules for electric car batteries. One deep-sea mining firm, the metals company, had actually funded some of the original research cruises. Then it turned around and issued a blistering rebuttal. Their argument: extraordinary claims need extraordinary evidence, and this doesn't have it. Their critics say the oxygen spikes were just trapped air bubbles, or stray electricity leaking from the fans that stir the chambers. They point out oxygen sometimes rose even with no nodules present. They accuse the team of cherry-picking data. That headline 0.95 volt reading, they call it a one-off fluke. No other nodule came close. And they note the paper never showed the hydrogen that electrolysis should also produce. It's not just the miners. Independent scientist Matthias Heckel ran his own deep-sea project in the same fields. His team took dozens of the same measurements. They never saw oxygen appearing out of nowhere. And 20 years ago, his group traced false oxygen spikes to, you guessed it, bubbles. Sweetman's team is standing firm. They point out the mining companies have a massive financial stake in this being wrong. They say they ran the controls, turned the stirring fans off, and the oxygen still spiked. They admit the effect may be intermittent, may be triggered when a lander scrapes fresh metal surfaces before the mud buries them again. And in 2026, the journal itself flagged the paper. An editor's note says aspects are under review. So, is dark oxygen real? Honestly, right now, nobody can say for sure. It is genuinely unresolved. But play it out. If dark oxygen is real, the stakes are enormous. For the whole story of life, we've assumed oxygen came first from sunlight. Tiny cyanobacteria in shallow water, photosynthesizing, slowly filling the air we breathe. These metal rocks have been sitting in the dark for billions of years. So maybe some oxygen didn't wait for the sun at all. Maybe it was sparking out of the rocks in the deep. A second, hidden source at the very start. It's a big maybe, but it's the kind of maybe that scientists can't ignore. And it doesn't stop at Earth. We've hunted for alien life on sunlit worlds, but look at Europa, a frozen moon of Jupiter hiding a liquid ocean under miles of ice, sealed away from any star. Jupiter's gravity flexes that moon and keeps its ocean liquid. And if there are metal nodules on that seafloor, they might be making oxygen in the dark too. That would change the whole equation for finding life. The dead corners of the universe, icy moons with buried oceans, might not be dead at all. So here's the real cliffhanger. A new expedition is heading down to the clarion-clipperton zone right now, with instruments built specifically to settle this. Is the deep sea breathing or not? What do you think they'll find down there? A glitch or a second origin for the air we breathe? Drop your call in the comments. If this rewired how you think about a single breath, hit like, share it with someone who's sure plants make all our oxygen, and subscribe with the bell. Next time, we're going somewhere even stranger. Until then, stay curious.